Obrigado, obrigado. I'll start in Portuguese just a little bit. Obrigado, pessoal, por estar aqui. Obrigado, Rogério e Leopoldo. Fico contente com o seu comentário agora. Até brinquei outro dia com você, né? Sempre me meti muito com os médicos, apesar de ser formado em psicologia, e agora meio que voltando às origens, né? Voltando para cá, assim, vindo para falar aqui no Instituto de Psicologia. Então, fico bem feliz mesmo de falar com colegas e pares. Então, eu vou virar a chavinha para falar inglês, para a Vicky poder acompanhar também. Today I'll be talking very briefly about our study that Rogério already mentioned briefly. It's the Germina cohort. So let me just... Okay. So I'll give a very, very brief introduction, just for the sake of time. So for the past 100 years or so, we scientists in health sciences are very much interested in understanding the diseases and mental disorders in terms of causality. We want to understand how these diseases and disorders come together, how they happen, how they affect individuals. And even though we discovered a lot in the past centuries or so, we still have a lot to learn. We made great strides in terms of infectious diseases and similar diseases. But in terms of mental disorders and some diseases, we still have a lot to learn. And in the past decades or so, we have been using this early life origins perspective to understand not only diseases, but also mental disorders. So we have to look at this picture to actually understand a little bit how behavior, symptoms, mental disorders come and actually happen in communities, individuals, societies. So we have to go back very, very early in life, even before life. Also, we have this transgenerational perspective nowadays that we assess families and then assess their babies and then the babies of the babies and so on and so on. So this is very much important. And also it's very important to try to understand every potential perspective that we can. So as you can see here, we need to understand the brain, we need to understand behavior, symptoms, but we all need to understand the genetics, the environment, and also at the molecular level. So if we don't embrace this complexity, we will not understand how these mental disorders and disease happen in humans. So we need to embrace these complexities, assessing individuals across time and considering all these potential data modalities. And then our major goal is to piece together this huge puzzle, very complex puzzle, piece by piece to understand how mental disorders and all other sorts of behavioral problems appear. So for this, because of this, we have the Germina study. It's a very big project that, as Rogério mentioned before, is led by Professor Guilherme Polanczyk at the Department of Psychiatry in the University of São Paulo Medical School. This is part of the Welcome Leap 1KD program, and that's how we met Vicky at first. She's also part of this program. So they were very generous in terms of funding, especially for Brazilian standards. So we got funding to run this cohort and also to collect, process, and analyze a series of biological data that I will show a little bit later in this presentation. And since this project is very big and very complex, we needed help from a lot of people and a lot of departments here at the University of São Paulo. So we had help from not only the medical school, but genetics department. We have people from the microbiome department. So it's very, very complex and big. We have a lot of collaborators, and of course also Rogério and Lizzie in this project. So the main goal of our cohort is to develop a fully integrated model of developmental data in the first years of life to predict executive functions at 3 years of age. This is our main goal in terms of the 1KD program, but we are not ending. We are not only focused on executive functions. We have enough data to try to predict all sorts of outcomes, behavioral outcomes, cognitive outcomes, early signs of mental disorders, and all other sorts of outcomes. But for the purpose of the 1KD program, we are focused on executive functions, okay? So I will talk a little bit about the methods, and I will not be able to mention every data, every variable, every characteristic, every outcome that we have, but I'll try my best to mention the broad domains that we have. So the first thing is that we have a prospective cohort. So the idea is to follow mother-infant diets across time. So we start at 3 months of age, so very, very early in life, as you can see. And then our idea is to follow them up to 36 months of age. In between our baseline and our endpoint here, we have T2, T3, and T4. And we have this sort of advanced, a little bit complex cohort design that groups of children are followed at different ages, so that we can collect data across all months, all age points, without having to analyze them every month. So we are trying to cover all the age range in between baseline and endpoint here. Okay, so our data is being collected at the Institute of Psychiatry, and we also had a lab at Educandário Dom Duarte. We don't have this lab anymore, so all the data collection is happening up to our Institute of Psychiatry. And just to mention a little bit how the data collection goes, so each time point that I showed here, we have 2 days of assessment. So from baseline to endpoint, the family will have all the families have an online assessment. So it usually goes around 3 to 4 hours, maybe more, maybe less, depending on the family. So we cover all questionnaires, scales, risk factors, and stuff like that. And then they also come to our lab. So in our lab, we have a variety of assessments. We collect biological data like saliva and feces to analyze the gut microbiome, and we also conduct developmental assessment using the Bailey scales and also EEG. So it's a very, very intensive data collection. I would say we are very, the families are very generous with us, I would say, because they have to come, they have to answer so many questions. At each time point, they probably have like 4 to 8 hours of assessment if we sum all together. So they are very generous with us, and I would like to thank every family that's been with us since the beginning of the project. And we have a very low dropout rate too. This is very, very interesting. So usually these families stay with us for this very long time. So this is just some pictures of our babies at the baseline doing the EEG. So as you can see, they really like, the families really like they enjoy the process of being assessed, because it's a very nice way to understand their infant's development, and we also give them feedback. So we have this, we have Instagram, we have a website. Maybe you can, if you are interested, you can look later. So a lot of the families like to post some photos and stories on Instagram to show how much their babies like the project. So this is the broad domains that we have in the Germina cohort. So of course we have the brain measures, and brain measures, I mean the EEG that we have in the project. We collect data about the environment, and here I use the word environment very, very broadly. So here I'm considering maternal mental health, I'm considering the home environment, risk factors, violence, and stuff like that. We also have behavior and cognition. We have a lot of scales trying to measure early signs of behavioral problems, mental disorders. We have the developmental milestones using the Bailey, social communication using the Vineland, and so on and so on. It's so many measures, it's not possible to mention all of them now. We also have, we collect biological data, like I mentioned before, genetics and epigenetics. So we have saliva from all the children. So we have their genetic profile and also their epigenetics profile, and also the gut microbiome. So we collect feces at 3 time points specifically to understand the role of the microbiome in influencing behavioral, cognition, the brain. And it's a very, very hot topic these days in health sciences. And our idea is to grab all these domain, all these data, all these variables, and implement some data integration models, because we collect so much data these days that it is not possible to run like the good old t-test, the good old linear regression. It's simply not feasible. We have like literally at this point thousands and thousands and thousands of variables. If you consider only the gut microbiome, for instance, Grover here probably knows better than most, we have thousands of variables. So it's not feasible to do like the good old statistics. So we have to implement some complex models to deal with so much data to try to predict executive functions, developmental milestones, and mental disorders, and so on and so on. So for the purpose of this presentation, I will show some of the preliminary data that we have at this point. We just submitted our first paper from our cohort. It's more of a methods paper, in fact. Our cohort, we have so many variables, so much stuff that we thought that it would be very important to have a methods paper, a paper that we could keep referencing in the years to come to help reviewers and our audience to understand our cohort, so we don't have to explain every time again how we did all the data collection. And it's not only a methods paper, but we also included some of the preliminary results considering only baseline. So only the data from 3 months of age, okay? It's probably a little bit difficult to see, but this diagram here is showing our recruitment process. So we did mostly online, social media, mouth-to-mouth recruitment. So we started with more than 1,000 potential subjects, and then we selected them based on some of the inclusion criteria that I can mention later, or you can read on our paper. So we ended up with 557 mother-infant diets. Okay, so this is our final sample at baseline. And this is a little bit of the characteristics of our sample. Okay, so this is the basic social demographic and economical characteristics at baseline. So since our recruitment was like I mentioned before, based on social media and using websites and Instagram and Facebook ads, we have a little bit of a bias. We don't have a representative sample. This is very important to understand. So we have a bias in terms of I think the most important variable to mention is income, family income. So we have families that are mostly middle class and upper middle class. And also in terms of skin color, the majority of them are white. So considering that Brazil, it's a very diverse country, we don't have a representative sample. And Yeah, so I don't think it's worth mentioning every bit of information here, but I think the takeaway message, it's not a really representative sample, but it's a very rich sample in terms of data, like I mentioned before. We have a lot of important data. So for the purpose of these findings, what we did is to take the Bailey scales. I believe most of you are probably familiar, but if you have some questions, we can answer later. So it's like the gold standard to assess development milestones these days, even though it has its flaws. So what we did is take all the 5 raw scores that we have in the Bailey. So cognition, language, and motricity, and we took all the raw scores and used a CFA model, a confirmatory factor analysis model, to extract a latent variable. Okay, so this latent variable composed of all the 5 raw scores was our outcome for the purpose of this analysis here. So it's basically a variable indicating how well the infant is developing at 3 months of age. And then we considered all these predictors that you see here. So these are broad domains, okay? So we considered socioeconomic and demographic variables. We considered maternal mental health, home environment, infant behavior, anthropometry, genetics, epigenetics, EEG, and microbiome. So inside each of these domains, we have dozens of variables, in some cases, hundreds of variables, and in some cases, thousands of variables, okay? So it's difficult to see, but it's just to understand a little bit the number of variables that we have in each domain, okay? So in our paper, you can send me an email later if you want to read. I can send you the link, and you have more information. But this is basically all the variables that we have across all domains, okay? So what we did, thanks to Grover, who is here in the audience, is to implement a machine learning model to try to select these variables. Okay, so this is a little bit technical and complex. If you have more questions, maybe we can answer later. But basically, the idea here is to find the best features that can predict our outcome using this idea of optimizing your data. So this is basically data-driven sparse partial least squares model that we end up, we can all the way to the data and to find the best features to predict our outcome, okay? So across all the domains and variables that I showed, we have these results that you see here, okay? So this is a coefficient plot. In the y-axis, you have the coefficient of a linear regression, and here in the y-axis, each row is a domain that I mentioned before, and each of these dots represents the coefficient. So the domains that showed that had a significant relationship with the outcome were socioeconomic and demographic variables, 2 EEG variables, one with a theta band, another with a beta band, epigenetics, and microbiome. All the other domains, we didn't reach a significant p-value, okay? So this is our main results at 3 months of age. So as you can see, we collected so much data, a lot of data, all the trouble, all the money spent, and then we end up having just these domains showing a significant prediction of our outcome, at least at 3 months of age. We don't know much about the other time points. And here, this second plot, it shows the what we call the relative importance. So each domain that I showed contributes to understanding the outcome, right? So here we have a percentage of how much contribution to the model. So if we remove each variable, how much would we lose in terms of information? So as you can see, the socioeconomic and demographic domain had the most importance. So we spent millions collecting biological data, and then we used some like very simple questionnaires asking some questions, and we have the best predicted value here. But of course, also the brain measures, specifically the EEG, was also very important. So yeah, and as you go down here, you see that some of the variables are not that important. Okay. So I think that's it for now. I just wanted to describe very briefly our cohort, just to show what we have been doing together with Rogério and Vicky, and also show some of the preliminary findings that we have. So one very important message for today, I would say, is that our cohort it's not publicly open, but we are open for proposals. So if you are a master's student, a PhD student, you can contact us, and we have a website with our code book. So we have like a data dictionary. We have all the variables, so you can look at our variables and you can propose an analysis, for instance. So, I'm very much interested in the role of parent-child interaction in cognitive development using the Bailey. So you can actually write a proposal for us, and then we assess the proposal, and then we can give the data. So we just have to make sure there's no overlap between the postdocs and students that we have working on the data now, no overlap between papers, and so on and so on. But we are very much open to people working with our data, because as you saw, we have thousands of variables, but not enough people to analyze. So we would like to have people to work with us, working with this data. And of course, I was not able to show everything that we are doing with this cohort, but you would be able to ask questions later. And then you can also email me, feel free to email me if you want. And you can also read our paper, the methods paper that I mentioned. It's not published yet, but you have the preprint, so you can actually read everything that I showed and understand all the variables. There's much more than I mentioned here at this presentation. So thank you for your time, and yeah, so that's it.